All right, let's get started. Welcome back, everybody. So today's lesson we're really using as an opportunity to reinforce what we started to learn yesterday about references. And we bring in this concept of polymorphism and how the reference type is related to what we can do with it, and sort of pointing out the difference between the reference type and the instance that it refers to. And so, as usual, I try to, when I'm picking the examples that I used at the top of the lesson, I really try to pick something that to me really sort of encapsulates the core idea that's being presented in that day's lesson. And here, I'll talk this through a little bit, and I hope that people will queue up some questions for us to address together. But here, what we're seeing is that, we'll go through this, line by line together, right? So I've created, and I've done this in the past, where we create a class that just has a void method that does nothing, and you may wonder, why am I doing this? The reason is that what I want you to see is the compiler's behavior. So the fact that this method doesn't do anything is sort of irrelevant. We're never really going to call it. What I want to show you is whether or not the compiler is even willing to compile this code or not. So I have a person class that has a speak method. So again, what does that mean? It means anything that is a person or extends person. Any class that has an is a relationship with person has a speak method. Then I extend person to create another class called student, and I add a learn method to the student class. So every student has a learn method. Not every person has a learn method. Every person has a speak method. Every student has a speak method because student extends person. And so student does not override speak, but it doesn't have to, because an instance of a student will inherit speak from its parent class, its superclass. If I extended student further, I could override speak in the subclass of student, or I could just inherit the person version of speak through student. Doesn't matter. But again, when a class defines a method, a public method, or in this case, these methods are packaged private, but it doesn't matter. I could put a public keyword on them, and this example would work identically. When a class defines a method that's not private, that method now becomes available on all classes that have an is a relationship with that class. So any instance of that class and any instance of any of its subclasses. Okay, so that's my little inheritance structure. And sort of going back to like last week and thinking about inheritance and how that works. Now I'm going to bring in references to the picture and a little bit of polymorphism here. So on line 8, I'm on the right side of line 8. I'm creating a student. This creates a new student object. And again, I see the new keyword. I know there's an object being created. I see student. So I know that this is an instance of student. Now we can think about the relationship that student has with other types of classes in Java. So a student is a student. Because a student extends person, a student also is a person. And because person extends object, implicitly a student is an object as well. On line 9, and so this is the critical difference here. On line 9, let me finish line 8. So on the right side of line 8, I create a new student, instance of student. And I assign that instance into a reference variable named student that's of type student. And so now we can really kind of understand how these two things are working. So on the right side, I'm creating an instance of a student. On the left side, I'm saving it into a variable that I've set up so that that variable can only store things that have an is a relationship with student. So for example, if I change this to be a person, then I'm going to get a compiler error on line 8, because Java says I can't convert a person into a student. I can't upcast I can't convert a person into a student. That's a downcast. I would have to do that using a cast, and it would fail. Because not every person is a student. And the variable that I've set up on the left side of this assignment on line 8 can only store students or anything that can behave like a student. So anything that has an is a relationship with students. Now on line 9, so here's where things get interesting, right? Because now we're bringing polymorphism here, references. So on line 9, on the left side of line 9, I create a new reference variable. This reference variable is called person. The type of this reference variable is person. Okay? And I'm copying the reference from student into person. So at this point, we've seen some diagrams about how this works. I have, one object, and I've got two references to it. We've seen this in the past. What's different here is that the references are different types. So one reference student is of type student, meaning that it can only store instances of student or anything that has an is a relationship with student. The second reference on line 9 is of type person, meaning that it can store anything that's a person or has an is a relationship with person. So that includes students, because students extend person. If I extended person using another class, I could also save instances of that class in this person reference. And of course, I can save person objects in that person reference. Okay. Now, what's interesting here is that fundamentally I only have one object in this program. That object is of class student. And so what we know about that object is that object has a learn method, and that object also has a speak method that's inherited through person. And it has equals and hash code and all those great things that we get from capital O object. But if I try to compile this code, what we see is that the compiler spits out an error. And the error is on line 12. And what the error says is that I can't call the learn method on my person reference. Now, what's interesting is that if I comment this out, the code runs fine. And you'll see that I am calling the learn method on this object, but I have to call it through the reference that has student type, not the reference that has person type. And so again, this kind of comes in. Now, this is weird, right? Because it's like I have one object, and I know that that object has a learn method. So why can't I call it using the reference that has type person? The real reason for this has to do with the fact that Java is going to enforce Java knows that I can store anything into this person reference variable that is a person. And Java also knows that not every person has a learn method. Only students in this example have learn methods. So I could do this, right? I could do new person. Now, if I do it this way, now this makes complete sense. I have two different objects. I have a student object and I have a person object. I know that the student object has a learn method, which is defined directly on the student class, and it also has a speak method, which is inherited from person. I know that the person object does not have a learn method because that was added by student when it extended person, but it does have a speak method because that's created directly on the person class. So now this compiler error would make more sense because I know that a person doesn't have a learn method because it's not part of the person class. Okay, so if I do things this way, now I think, even before we had this conversation, you would have agreed with me that this wouldn't work because it's like, using dot notation to call something, but it doesn't, person doesn't have that method. What's new here is having to think about the case where person actually refers to something that has a learn method. And even in that case, I can't call it. Now, the reason for this, again, has to do with the type that we've applied to the reference variable. And one of the main lessons contained in this lesson, or the main takeaways from this lesson, is that when you use dot notation, Java uses the type of the reference variable to determine whether or not you can call a method. It does not use the type of the instance. And one of the reasons for that is it doesn't know what the type of the instance is. The type of the instance might change at runtime. So here's a great example of this, right? So let's think, okay, so at this point, and now I could say person is equal to new person, and I could do this. Well, actually, you know what? Let's have some fun here. So we're gonna use. We'll talk about imports actually later this week, which would be a lot of fun. But for now, what I'm doing here is I'm importing a package that allows me to use randomness in my code. I'm going to create a new instance of that. And now what I'm going to do is the following. So I'm going to say person, and then I'll say if random.next boolean. And so what this method does is it returns true half the time and false half the time. And so I'll say half the time I'm going to set my person reference variable to be a student, and the other half the time I'll set it to be an actual person, right? And so now I know that this can't work, right? So again, what I'm trying to tell you is that Java can't evaluate whether or not it can call speak at compile time because it depends on how the program runs. It depends on the behavior of the program. So in this case, again, I've created a person reference variable. I don't initialize it. Instead, what I do is at runtime, I call this random.nextBoolean method, which we'll talk about later. Randomness tends to be actually really interesting and useful. And so in this case, what I'm doing is I'm saying, okay, half the time when I run this, and I can put a print statement here, and then we'll eliminate the compiler error so this can actually run. So I say student, and then half the time person, and then I'll do, so you'll see sometimes person, sometimes student. You know, I get runs of each, but it's trading off back and forth. All right, so it's again, to come to the takeaway, it's the reference type. It's the type of the reference variable that gets used when we determine whether or not we can call certain methods on an object, not the instance type. This differs from other programming languages in some important ways. So for example, some of you have learned the language Python. Python has something that it refers to as duck typing. And what duck typing means, it's kind of a stupid phrase because it's not really typing at all. What duck typing means is that Python will try to call a speak method on the instance of if you have a variable in Python, you try to use dot notation to call. Python has classes just like Java, so if I try to use a call a method, Python will just try to figure out if that object has that method and call it if it does, and if not, it causes an error to take place. So the idea behind, and you can look this up, right? So duck typing basically says if my class, and actually there's kind of a nice example of this, right? If my class has a method that matches the signature I'm trying to call that method. There are no class relationships that are required for this to work. So again, let me blow this up so we can see it. This is a nice example of this in Python, right? And some of you don't know Python, some of you do know Python, but you know, even those of you that don't know Python can probably squint at this hard enough to figure out what's going on. So this is a class declaration in Python. Python syntax is quite different. There are no, Python uses indentation to create blocks rather than braces, but this is a Python object. This is the definition of a Python method. Don't worry about the rest of it. This is a method called fly that takes no arguments. You'll see that both duck and sparrow have a fly method. Whale does not have a fly method. But I can go through a series of instances of duck, sparrow, and whale, and I just try calling fly. And the idea is that because duck and sparrow have a fly method, that works because they have that method. So basically, I'm using dot notation. Some of this should look actually pretty familiar to you now, even if you've never seen Python before. Python also uses dot notation to call a method on an instance of an object. And the idea is that, you know, when I call this on a particular type of class, if it has that method, it gets called. If it doesn't have that method, you get an error, right? And so the Python compiler doesn't help you at all here, right? It just says, okay, well, good luck. I hope it works, you know? And so in Java, the Java compiler has to be able to convince itself. It has to know that an object has a particular method before it's willing to try to even compile your code. And so that's why you get this particular error. All right. Questions about this stuff before I go on, and we can talk about some of the other ideas that come up in this section. You know, mainly the main nugget in this lesson is what we've already talked about, and then we go through some examples of, you know, other places where references get used, and we talk a little bit about arrays and stuff like that. But that stuff's in the lesson, so I don't feel like I need to harp on it. So what I'd rather do for the next 20 minutes or so is just take some questions about this topic and try to work through it together and figure things out. So fire away. I'll hang out while people come up with some questions, and then we'll talk it through. Oh, come on, you guys have to have questions. Stuff's so interesting. Ask away. Unfortunately, as far as I can tell, neither my dog nor my cat has any interest in this topic. So I'd ask them for questions. Do declarations of non-primitives? Yeah. So the question is like, some of you that might be familiar with pointers from C or C++, is this a similar idea? Kind of. It's a little bit more complex. But it's not a terrible analogy. The only reason that I caution you a little bit about this particular type of thinking is because it turns out that C++, for example, now also has something called references, which are different than pointers and are much, in some ways, more similar to the references that we're talking about here. Let me try to kind of illustrate the difference. So one of the things that you probably noticed about Java is that if you use a language like C and you have a pointer, you can actually inspect the contents of the pointer. Like C will tell you what's in that variable if you ask it the right way. So your pointer might be, the pointer is just a number. A reference in Java is just a number as well, but everything in a computer is a number. It's how it's interpreted. A pointer is a number that the computer, the program will expose to you as the programmer. So for example, you can take a pointer in C++ and you can like add stuff to it. You can treat it like it's a number. You can do math. This is called pointer arithmetic. And certain types of data structures will do this. When you go on and take CS225, I'm pretty sure there's some places where you'll actually do pointer arithmetic. So you will take a pointer, which is a number internally, and you'll treat it like a number in order to do things that move the part of memory that you're using around in ways that allows you to access certain things, right? There is no way to do this in Java with the reference. Java will not give you the contents of a reference variable. There's no way to like add to it or even print it. I mean, the closest thing you can do is you can use the default print method, which does actually display the memory the memory location of a particular object. But so one of the reasons for this is because we'll talk a little bit about this tomorrow when we get to do a lesson where we look into a little bit of the internals of Java memory management. Java itself, so if, again, this is a tricky distinction. If I tell you where something is in memory, then I kind of am stuck with that location, right? So as soon as I expose that location to the program, I need to have agreements about things like, for example, the location can't change. In Java, because of how Java uses references, it makes it possible for Java to move things around internally. So the reference that Java uses to access an object, while it does at any given point in time, I mean, again, we'll talk about this tomorrow. I mean, everything you create in your Java programs has to be stored in memory somewhere. So at any given point, any instance of an object has a memory location, right? Like, you got some chips of memory in the computer somewhere, and you could point, maybe even almost. Like there's a physical location, and then there's several different types of semantic location where that data is actually stored in memory on your computer as the program is running, right? That is a fact. The difference between a pointer and reference is how visible that location is to the program. So again, in Java, you have no way of using that information. You can refer to the variable and Java will find it for you, but you don't know where it is. And so maybe okay, so here's my attempted analogy. Maybe, I feel like I'm coming up with these analogies now that are all like driven by stuff I used to do before we were stuck inside for a year. But there was a time when I used, my wife and I used to like to go to a museum. And, like there's a coat rack, and sometimes when you go in, some museums have a place where you can like save your coat, right? And you give them the coat and they give you back this little, ticket. That's a reference. That ticket is a reference. Where my coat is in the coat room, I don't know. I know that I can get at my coat whenever I want to by coming back and giving the reference to the person that's there, and they'll translate it for me, right? They'll go find it. but I don't know where the code is, right? I don't, and it doesn't matter where it is. It can move around. So for example, maybe at some point in the day, they have a bunch of people leave and there's one coat rack's getting too crowded and another coat rack's free. And so some attendant goes back and moves all the coats around. And so my coat, which was in one place, ended up in a different place. And I don't care because I never knew where it was in the first place. I still have a reference that I can translate to sort of get at my coat whenever I want to. I've got that reference, but I don't need to know exactly where it is. And that's really kind of how Java works internally. So as a Java program runs, the memory locations of stuff can change and do change over time. There are times when Java will need to move things around internally in order to free up some memory or make more efficient use of resources. And so I think that's kind of the fundamental difference between a pointer and a reference. When you provide information to the program about where something is in memory, direct information, then it's much more difficult to move things around. And this is actually a problem that certain types of programs have because they allow you to basically determine exactly where something is in memory, and then there's no way to move it around later, right? That information is now part of your program, and if I don't really have a mechanism for moving things. Whereas with Java references, because that reference is opaque, it's not visible to the programmer. There's no way for you in your program to get any information about where something is in memory. Java gives you this reference variable, and there's stuff in there. Obviously, there's some number in there, and we can peek at it using toString. But there's no way to actually get that location, right? And the reason, and again, you might think, well, why not? I mean, it sounds like, why doesn't Java use pointers? Like, why wouldn't it give me that information? But this is actually one of the things that's super powerful about references and makes them so useful for a lot of different types of resources in computer science. Once I have a reference and I create a process for translating it, that gives the entity that does the translation now has a lot of flexibility in terms of how the reference is translated. So again, let's go back to thinking about some of our other examples of references. So, a street address. Like sometimes, this does happen. Streets will renumber, So a street will decide, okay, well, we need to change the numbering here, and they'll renumber all the addresses on the street. And as long as, your mapping software knows where the new number is, you don't care, right? So the address might move somewhere else and you're still going to find your way to the right spot. A better example here is probably a phone number. So the phone company is responsible for translating that reference. So when you type it in, the phone company goes through this process of figuring out, okay, what device should ring? And where is that device? Because it needs to, it's really what device should ring. And then it finds the device and sends it a signal and it starts to ring. And that all happens, within a fraction of a second after you place a call. It's pretty cool. But let's say that you get a new phone. You don't want to change your number, right? And so what you do is you negotiate through the phone company to change the mapping, okay? If the phone company, so let's imagine, so a pointer is almost like you have a number that's directly linked to a physical device. And so when you get a new device, you can't use the same number because it still points to this other thing. Every phone actually does have this unique identifier baked into it that's different than every other phone on Earth. And that's important for a variety of reasons. But the phone number itself is this reference that can change because it's translated by the phone company. So when you get a new phone, you call them up and you say, hey, I got this new device. Usually you do it online now. A couple minutes later, they've adjusted their bookkeeping so that when somebody calls that number that you've been using for 10 years, it now rings on a new device. There's other aspects of control that having references also gives you access to. So for example, if you don't pay your phone bill for a while, the phone company can start to refuse to translate that reference. They can say, okay, well, your phone's not going to ring until you pay up, because they're responsible for translating that reference. So they don't have to. And this is something, again, there are a bunch of places where references get used in computer science, and it's for these reasons. So yeah, they're similar in concept to pointer, but with some really important semantic differences, which hopefully I've outlined. But that's a really, really interesting question. I think one of the things that I would say is Java only has references. And so it's hard to see the distinction between the two. At some point, you're going to learn a language, probably next semester or in 2 semesters, called C++, that actually has both. And at that point, think about what the differences are, right? Think about, okay, what can I do with a pointer that I can't do with a reference, and why, right? Why am I allowed to do those things with a pointer, and why is it not possible for me to do those things with a reference? And I think that will become more clear at that point. But yeah, I mean, on some level, Java references are, Java uses references as a replacement for pointers in other languages. So, great question. Again, we'll come back and we'll talk a little bit about, tomorrow's lesson is entirely on Java memory management, and so we'll dig into this topic a little bit. And at least the reason why it comes up at this point is because this is a place where Java gets to use references in order to do cool stuff, right? Specifically, and again, we'll go into this tomorrow. The way that, so you might have noticed in Java, there's no delete, right? I have a way of creating a new object, which takes up space in memory. I have no way of deleting that object. So how does Java get rid of stuff? And one of the things that, and again, you really can't do this in the same way with pointers. One of the things that Java does with reference variables is it uses them to track how many like when an object is alive, basically, yes. So, garbage collection is a technique, but you actually need to be able to know what objects are alive, right? What objects can still be used in your program. And we talked about this a little bit with references, this idea of if I don't have a reference to something anymore, it might as well be gone. It might as well not exist. If there's a house in the forest with no address to it, if somebody goes and destroys that house, nobody knows, because no one knew where the house was in the first place, right? And so this is essentially the trick that Java and many other languages use to automatically limit the memory usage of your program, which is they say, as soon as you don't have a reference to an object anymore, it's gone. And when it's gone to you, Java takes care of freeing up the resources that it consumed. So once you don't have a reference to something, you can't access it in your program. If you can't access it in your program, it might as well not be there. If it might as well not be there, we might as well not have it be there and take up memory. And that's when that memory actually gets released. So it's a really neat idea. And again, the idea of doing garbage collection using reference counting is basically something that's done in many, many major programming languages at this point. So it's a very cool idea that, again, is made possible by the idea of a reference. So, cool question. Other questions? A few minutes left. Man, that was a great question. Thanks, Luis. That was really interesting. That's fun stuff to talk about, though. Other questions about this before we call it a day? So today's homework problem is on shallow copying. You'll have another chance to do a deep copy tomorrow, but we talk about kind of both those concepts. So just in case you were wondering, tomorrow we'll give you a deep copy homework problem just to kind of drive in the distinction, kind of show you how to do things both ways. In general, deep copies in Java are much more problematic because in order to do a deep copy, the object has to support it. And in order for an object to support a deep copy, any of the fields that it uses also have to support it. And so if I have an object that has instance variables that are also objects, in order to really copy the whole thing, all of the types of my fields have to always also support some type of copy operator. And I have to use it in my copy constructor. So yeah, it's just this is sort of a mess. But you can think about, if your class uses other classes internally, if some of those classes don't support copying, then there's really no way for your class to support doing a full copy operation. So that's the trick with that. Yeah, references are cool. References are just kind of one of these great ideas in computer science that you see. I taught a class on operating systems for a long time, and we talked about references. I taught a class on the internet, we talked about references. I mean, they get used, this is just a really, really powerful idea, this idea of giving you something symbolic that is not, email addresses are a reference, right? URLs are a reference. Like references are just all over the place. And in all those cases, using that reference involves a process of translation to a much less user-friendly form, right? Which is kind of the same thing that happens in Java with references. And so we'll talk later in the semester when we talk a little bit about the web, about another place where references come up. Because like I said, they just come up all over the place, and it's just like a tremendously powerful and durable idea in computer science. Source code of the playground. The source code of the playground is public. Well, the backend at least. So the playground backend's available. I'm gonna find a link for you. Yeah. So the backend for the playground is here. That's actively maintained. You can see the last commit was 6 days ago. This is a project we've been working on now for over a year. So that's out there. Like you could run that on your own machine if you wanted to. But that's just the back end, right? But that's the interesting part, really, right? I mean, the front end is, so the back end actually does the interesting work of you give it some Java code and it runs it, compiles it, runs it, collects the output along with a bunch of other information and sends it back. So that's really, the front end, you could write 10 different front ends for it. They just have to be able to actually, there has to be a process by which, in the front end, it's like when you hit play or when you hit control enter, we take the code in the browser, we ship it back to our army of, I think there's like 8 of these that we use to try to provide better latency. So one of 8 cloud servers takes the text, compiles it, executes it, collects the output of the error messages, sends it back to the front end, and you're good. In fact, hold on a sec. Did I leave logging on? Sometimes I'll leave the logging on for this feature. Oh yeah, there it is. So this is, it's just because Ben asked. Let me blow this up a little bit. So this is actually the information that's coming back from the back end. And in this case, you can see that it failed compilation, and then there's information about the error messages and where they occurred. And then there's some information about the request itself. So here's the code that we actually sent. Here's what we asked the backend to do. We asked it to compile it, to run check style, to do complexity analysis, which we've been doing on all your code, but we don't really show you the results. Sometimes actually some of the errors we've been having are because of that. I don't know, I forgot that I left that on. We use this snippet preprocessor that allows us to write loose code. We'll talk a little bit more about that soon, and then we execute the code if it compiles, and in this case it didn't. So that's but all all the interesting part here is really being done by the code of the project that I linked to, and in particular, a lot of the subtlety or the difficulty here has to do with doing this safely. So we don't want you to be able to crash our grading servers. Let's see here. We looked at this before, right? So without doing anything smart, this would have been a problem, right? Like system.exit actually shuts down the JVM that's running the program. So had we not at least taken some precautions, this type of code would have caused problems for us. But we've done quite a few things actually to try to provide a safe sandbox. I'm not sure that we've closed off every single possible opportunity for you guys to cause trouble, but we did a lot. There was a former core staff member named Ben Nordic, actually, who graduated last year, who picked up a lot of understanding about bytecode engineering, which we use pretty heavily to defend against certain types of attacks. So we do a lot of obvious things to make sure that you can't just do stupid stuff, and then there's some subtle things to make sure that you can't do certain types of attacks. I don't think you guys are actively attacking our backend, but it helps to avoid just sort of dumb stuff, right? Same thing with timeouts, right? I mean, if you write something like this, we want to be able to shut that down. Put a statement in here so the text file isn't angry. So this, we need to be able to handle runaway code, various types of runaway code. If you look actually at the test cases in the project that I linked you to, you'll see there's lots of tests for various types of malicious code in terms of various types of runaway code that we shut down. So that's actually where a lot of the fun is. What's fascinating to me about this, and since I'm almost out of time, I'll allow myself to go off on a tangent. So a lot of other, so essentially, I'm trying to think of the right way to explain this. We take your code, we compile it into that bytecode representation, and then we run the bytecode inside a Java program that's already running. And with many other programming languages, there's no way to do anything like this. You can't do it in Python. You can do it in JavaScript. You can't do it safely. Some of these languages have ways for you to do it, but there's no way to make it safe, right? So if I try to do this in Python, there's zero way to make it safe. So you can do it if you trust the code that you're about to run, but I could write, like an exit type statement like I just did, and that would cause the whole program to exit, which is not good. The reason why Java has these features, this is really funny, is this feature of Java that almost nobody knows about anymore because it's basically been wiped from the face of the web, and that's applets. So years and years ago, Java, was positioning itself as the way that you would run code in the browser. So this was very, very early on in the web, and people were looking for a way to make the web more interactive. How do we create web applications? I mean, to some degree, the web that most of you knew and have grown up with, at least for the past 10, 15 years, has always been the interactive web. But there was a time and a place where the web was much, much simpler, where it barely did anything. It was like sending you a document or something. And so there was a push by Java to establish itself as the way that you would run interactive web applications. And the way that they propose to do that is through this idea called applets. So the way applets worked is you can essentially think of it as when you loaded the page, your browser would request compiled Java code from the server. The server would send you compiled Java code, and you would run it in your browser. And so in order to try to support this, Java built in a bunch of security features into the Java virtual machine that are designed to allow this type of thing to happen. As far as I know, these security features are almost basically unused anymore because nobody runs Java applets. But in our case, they turn out to have this really sort of beautiful second life to them because we're now using some of those features to try to make your code safe, right? So for example, if you look at the error message that you're getting here when you try to shut down our backend, not very nice. This access control exception, this exists because of Java applets, right? Because again, you wouldn't want a Java applet just to be able to crash your browser. And so all these security features that Java built in like over a decade ago, that probably haven't been, well, I shouldn't say over a decade ago, probably 2 decades ago at least. Probably maybe 3 decades ago. I mean, let's see here. You guys may be curious. Java applets. I love how they use the past tense here because it's totally appropriate. Were small applications. I mean, there aren't a lot of things in tech that you can find where the Wikipedia page uses the past tense. Like, there aren't a lot of things in tech that we've just totally put in the rear view. Like people are still running Fortran, right? Fortran would use the present tense in its Wikipedia page, but Java applets do not. Let's see, they were first version of Java in 95, beginning in 2013. Most applets were completely unable to run by 2015, 2017. So last 3 years, we've basically wiped applets from the face of the earth. And this is a 25-year-old technology. Happily, because this is how programming languages work, the features that applets require to run are still hanging out in the Java virtual machine, just waiting for us to use them for this purpose. So it's kind of a neat story. Mentioned we would do more things with the web. We're going to look at how to use sort of back-end web APIs, but that's about it. Java is not a web development language. On some level, here's the problem. And again, this is just one of these things about Java that you just sort of have to deal with. Java doesn't run in the browser, right? Hasn't, Java Applets, when did they say they started phasing them out? 7 years ago? From 5 years ago, actually even earlier than that, Java Applets don't run anymore. So there's no way to run Java code in the browser. Can you just use Java on a server to generate a web page? You can, but that's not interesting. You guys wouldn't find that to be very cool, right? We could do that, and I think you would think it was pretty dumb. And I think if you showed it to your friends, they'd think it was pretty dumb. Because we're all used to to Java, Java as we're used to the interactive web, right? If I give you a web page that doesn't have any buttons and just is a bunch of it's going to look old-fashioned and dull to you. And so that's about what you can do with using only Java online. The reason we use Android is because you can actually build a real full interactive application in Java using Android. I would argue that Android has its own way of doing certain things, but a lot of the high-level concepts are very similar, right? So you need a way to display stuff on the screen. You need a way to handle certain types of events. You need a way a push a button or whatever. You need those types of things. So yeah, those are not those are not stuff that's done easily in Java on the web. If you want to take a look at our playground and mess around with it, absolutely. Go for it. And the only reason I feel comfortable saying that is because there was another Ben that came before you that I suspect has tightened down many of the hatches here. But yeah, feel free to give it a try. There's, like I said, if you open that project up in IntelliJ, you'll find, particularly in the part of the code that actually represents the sandbox, where we're trying to keep things secure. There are, 100 tests for that part of the project, including quite sort of significant tests of the various security features. Ben Nordic was kind of the person who knew all of these weird things about Java that I didn't even know existed, right? Like finalizers. Java has this notion of an object finalizer that you can create. No one uses this, but Ben made sure that those were safe. So anyway, yeah, go to it. If you find at some point I thought, maybe we would try to release this for other people to use, at which point I would probably try to put some bounty on examples that show how you can escape the sandbox. We found some of them, actually. When we started to use this for Kotlin, we found some problems that we had to hunt down and figure out how to deal with, and Ben did a lot of work in that area as well. I'm less convinced that our Kotlin support is airtight. There may be still some escape hatches there where you can get out and cause trouble. The support for Java, I suspect, is pretty good. But if you find some problems, then I will, at this point, I will reward you with the opportunity to commit that test case, and then if you feel up to it, figure out how to fix it. I have 3 minutes left. I do like talking about this, but so the other thing I want to make clear is that we actually don't run your code unmodified. So there's actually 2 steps. We compile it to bytecode, and then we run it through a process where we take your bytecode and we make some small modifications to it. And those modifications are made in order to make it more safe. And so right now, the bytecode modification that we're doing is pretty light. There's only a few places where we totally got stuck and couldn't figure. We basically did this as a last resort. We said, we don't want to make these changes unless we can really, we can't do things in any other way. But there's a few places where the Java security model is not sufficient. And so we had to do some very light bytecode editing. Those places work, right, which is pretty cool. But that's another tool in our belt that we have. So, we don't just trust the output of the compiler. We run the compiled bytecode through a transformer that helps to close off a couple of lines of attack. So yeah, by all means, go cause trouble. All right, I've certainly wandered off on a tangent, but I'll be back tomorrow. And tomorrow is tangent day. So tomorrow we're going to talk about memory management. This gives us a chance to see how references are used, and it's also kind of cool. So I will see you all then.